name's Phil. I'm here with Grin Technologies. We're going to be doing a tutorial today on diagnosing and replacing Mosfets on a motor controller. We're going to be doing on a Grinfinion controller, but you could use the same steps for practically any controller that has Mosfets. The tools that we're going to need are a multimeter. We're going to need some hand tools to get inside the controller, so some Phillips screwdrivers. And then we're going to need some pliers, some side cutters to remove the damaged Mosfet. And then of course our soldering equipment that we're going to need to solder in the replacement Mosfet. So the first thing we'll do is we'll start with diagnosing. So what you might notice when you have a damaged controller with damaged Mosfets, that obviously the motor's not going to spin, it's not going to work. The motor may judder back and forth. That may be an indication that the Mosfets are damaged. The other thing that you can do, powering the bike off, if you spin the motor by hand and there's significant resistance or kind of cogging, that would indicate also that there's a shorted Mosfet. On geared motors, that's only going to be felt when they're spun backwards. So once you have an indication that you're likely dealing with a failed Mosfet, the next step is going to be to get your multimeter. You're going to set it to resistance mode. I like to use 20 k ohms or 20,000 ohms. And you're going to start probing the phase wires to the battery positive and the battery negative on the controller here. So this 20 amp controller that we have right here, it's got the Hygo style motor connectors on it. Makes it a little bit trickier to find the Hall wires inside this connector, but there's actually 3 Hall wires, and if you look down the connector you can see that they're slightly larger than the rest of the Hall wire connectors inside there. So as we can see here, we're testing in between the battery minus on the Anderson, and we got our pin inside one of the phase wire connectors inside there. Kind of tricky to see, but we can see that our resistance is about 5 k ohms from the phase connector to the negative on the Anderson. If we go over to the positive, we'll see our resistance at about 8 k, and it's increasing as the capacitors are charged inside the controller. Either way, that's indicating of a proper operating Mosfet. So that's not where our problem is. If we jump over to one of the other phase wire pins, check again, we see the resistance on the meter showing 0 ohms, so that's a dead short. If we go into diode mode here as well and check again, we see we have full continuity to battery minus. That's indicating a shorted Mosfet on that side. So that's going to be where our problem is. The next step is going to be to take it apart. Now, one thing I'll mention briefly, on this controller we have a Hygo plug. There's many different styles of plugs for many different motors. A typical one that we sell as well is the Anderson. You would test it the same way. In fact, it's easier to test the phase wires to the battery plus and negative for shorting because they're just easier to reach, and also you can actually see what color ends up having the shorted Mosfet. On this Hygo plug we can't see what color that is, so we're going to have to actually get inside the controller and test that again. So I'm going to go ahead and take this apart now. We'll start by taking the back plate off. We'll take the front plate screws off as well, and then we'll actually have to take the Mosfet securing screws out of the side as well. So I'll start with that. Cool. Pop that back cover off, turn it sideways, and we're just going to slide the whole body off of the control board just like that. We can set that aside. And now we have easy access to our Mosfets. In this case we have 6. So each phase is actually going to have a positive and a negative Mosfet. In our case, since we know that we had a short to battery minus or negative, we're going to be looking for a faulty negative Mosfet. Since we have a Hygo plug, we can't really tell what color it was that had the short, so we're going to put it back into diode mode or continuity mode, and we're going to probe along our phase wires and try to identify which one had the short to ground. So we're going to grab our battery connector again here, put it in the ground there, and we're going to probe along our yellow, green, and blue wires right where they go through the PCB, and we're actually going to see which one has continuity to ground here. Test the yellow one first, nothing there. Test the green, and there we have the short. We'll test blue, just to be safe. That one's good, no continuity. So our short is definitely on our green wire phase. It's going to be the negative Mosfet of whichever one of these is negative. So that's the next thing that we're going to identify, is which Mosfet is positive and which Mosfet is negative. We're going to do that by going to battery plus. You can either do it on the Anderson here, or if you know where battery plus is on the controller, you can do it there. We'll just keep doing it on the Anderson since that's what we know for sure. We're going to go to battery plus on the Anderson, and we're going to touch the bodies of the Mosfets here. So that's continuity, so that's a positive Mosfet there. No continuity there. Continuity there. Nothing. Nothing. So this is positive Mosfet, that's a positive Mosfet, and this one here is also a positive Mosfet, leaving the remaining 3 negative Mosfets. So we now know that we have a failed Mosfet here, and we know it's going to be a negative side Mosfet because it was shorting to battery minus, so this is going to be our bad Mosfet. It's not always clear physically that they're bad. We have no signs of damage on this one, no burning, no scorch marks. The Mosfet appears to be physically sound, but it is most definitely shorted. We're going to have to unscrew it from the heatsink, and we're going to have to solder it out. So let's go ahead and take that screw off. Most often they're Phillips. And this is a point where having gloves is nice because the thermal compound on the heatsink here is nice to keep off your hands. So once we've done that, we can go ahead and separate that Mosfet from the heatsink board, just like that. Now that Mosfet's isolated from the heatsink, we're going to go ahead and flip it over, and we're going to desolder it by desoldering these 3 legs at the same time and just have the Mosfet fall out. So there's a few different techniques on soldering out Mosfets. The technique that I like to use is just applying lots of solder, joining all 3 of those pins together, the large pool of solder, and then the whole Mosfet should just drop right out with gravity if you're holding it upside down. You can use a desoldering tool to try to desolder the legs. You can try to wiggle them out kind of one by one as you pull on it. I find that the gravity technique works the best way. Worst case, you can always cut the legs of the Mosfet, and then that way you can take the Mosfet out and then just desolder the legs out of the holes individually. That's kind of an easy way to do it as well. I'm going to try the gravity technique because I think it's pretty easy and it works pretty good. Alright, so it didn't quite fall out as we intended. I think what we're going to do now is just cut the legs off, and then we can clear the holes using a solder sucking tool, and then we're ready to install our new Mosfet. There we are. Damaged Mosfet is out, and now we got to get those legs out of there. Boom. We're going to use a solder sucking tool. It's a pretty convenient way to clear a hole of solder and get it ready to slide the new component in. Here we go, we're going to insert our Mosfet into those holes that we prepared. You're going to want to make sure you got the right Mosfets. For this one, it's an AT460 Mosfet. There we are. You're going to want to make sure you line it up with the hole. Get it close enough. We're going to go ahead and screw that in before we solder it in so we know that it's in the right place. I'm going to go ahead and flip it over. We see we bent our legs out of the way here. We're going to straighten those out. And now we're ready to solder those legs back into place. Just like that. Boom. There we are. Looks pretty good. Now that we have that MOSFET in place, we can just confirm that it is in fact working properly now. We're going to check the same way that we did before when we had that short. We're going to go to battery minus, and we're going to check against the body of that MOSFET. No continuity, so that indicates that that was in fact the shorted MOSFET, and I think that we're good to go now. We can put it back together and give it a test. Now that we're ready to put it back together again, we can straighten our heatsink board, straighten that back into place. We're going to slide everything back inside the case. You're going to gently tuck in the wiring as you go. Alright, now that we're all back together, Humpty Dumpty's back together again. We're ready to test this thing out and see if our repair was successful.
And she works.